Welcome back to Mathematics Lifeline. Today, I'd like to explain what the product rule is and how to use it when solving a derivative. So, a lot of times we're going to have terms and functions where there's going to be two things being multiplied together. So let's take the example of x plus 3 times x plus 2. So, I know that a lot of you would think, okay, well, we have a derivative of this whole entire function. We want to find the derivative of this. So we'll just take the derivative of this one and multiply it by the derivative of that one. Well, there is a problem with that. You can't actually multiply derivatives. You can add them, you can subtract them, but you cannot multiply or divide them. So what we have to do here is something totally different than what I think you would think. This is the product rule. We're saying let's take the first term times the derivative of the second plus the second term times the derivative of the first. So this is the first term and this is the second term. So what we have to do here is we're going to take this first term being multiplied. That's our x plus 3. So we have x plus 3. And we're going to multiply that by the derivative of the second term. So this is our second. So the derivative of this, well, we know the derivative of x is just going to be 1 from our power rule. And we know that the derivative of 2 is going to be 0. So this is just x plus 3 times 1 plus, well, now we have to do the second part. So we have the second term right here. So this is x plus 2 times the derivative of the first. So the derivative of this one is just 1 again, because our derivative of x is 1 and our derivative of 3 is 0 times 1. Now what we can do is we can go ahead and simplify this. So we have x plus 3 times 1 is just going to be x plus 3 plus, now we have x plus 2 times 1, that's just going to be x plus 2. Now we can go ahead and combine our like terms. We get 2x plus 5. That is our derivative using the product rule. Now what some of you are going to notice too is I did something like this in a previous video on the power rule where I just FOILed these together. And you can do that. So if we FOIL this out, we're going to end up with x squared plus 5x plus 6. Now we can use the power rule to find the derivative of this. This is just going to be 2x plus 5. Just using the power rule here. And you see how much faster that is than doing the product rule. So the product rule most of the time is only used for functions that you cannot simplify and multiply together. So if you have two functions that you can't multiply, that's when we're really going to use the product rule. Because this way just saves so much more time. This way works perfectly fine. If you like the product rule, you can use the product rule for something like this. I just wouldn't recommend it because I think that this way is so much quicker, just doing it by FOILing and then doing the power rule. But let me show you an example where you can't do that. Let's say that we have the function that we want to find the derivative of. We're going to say e to the x times sine of x. This is a case where we're going to have to use the product rule because the product rule is only really used for terms that we can't multiply. We see that we can't simplify these. These don't come together nicely into one term. They just can't. So what we're going to have to do is do the product rule here. So let's start with that. Let's say the first term, which we know is our e to the x, times the derivative of the second. Well, the derivative of sine x is cosine x. That's one that we need to have memorized. I do have a video out on this on my channel. It's about some basic derivatives that you need to have memorized. I'll link to that in the description if you haven't seen that video. But yeah, we need to know the derivative of sine is cosine. So let's do the same thing on this other side. So now we have the second term, which is our sine x, times the derivative of the first. Well, again, in that video, I went over the derivative of e to the x. The derivative of e to the x is itself. It's going to be e to the x. So now we've finished the calculus. Now let's just simplify it. We've done all the calculus. We did the product rule. We found the derivative. Now, this is technically the right answer. But a lot of times your professor is going to want you to simplify this. So let's go ahead and do that. So we have, on the left side, e to the x cosine x plus e to the x sine x. And one last thing that we can do is factor out an e to the x. We have it in both terms, so we can bring that on the outside. e to the x times cosine of x plus sine of x. And that right there is your derivative of e to the x sine of x. And that's using the product rule. So you can see that there's no other way that we can FOIL this. We can't combine these together. It doesn't make it any easier. So we have to use the product rule for something like this. So let me give you another example. Let's say that we want to take the derivative of the function x squared times ln of x. Remember, ln is our natural log. We know the derivative of that, so we'll use that right here. So let's take the first term. We're just going to leave that one alone. X squared times the derivative of the natural log of x. Again, if you haven't seen my video, it's in that video. I'll link it in the description if you need to know it. The derivative of ln of x is just going to be 1 over x. Now we have plus the second term, which is our ln of x, times the derivative of x squared using the power rule. That's going to be 2x. And now again, this is the right answer. This is what you want, but we do need to simplify this. So this right here is the same thing as x squared over x. When we multiply the x squared times the 1 over x, those become x squared over x. Now we have an x squared over x. We can cancel an x out, change this into a 1. We're left with just x on this side. X squared divided by x is just going to be x. Now, I'm just going to be nice and bring this 2x out to the front. So 2x ln x, that right there is your derivative. So it's really nice because it's just a set rule. It's just something that we can follow every time. You're always going to be able to do this. We'll do one more example for you. Using something that we cannot distribute together. So let's take the derivative of, let's say, sine x times cosine of x. So what we have here is another product rule. We see these are being multiplied together, so let's go ahead and do this. We have the first term, which is just our sine x, times the derivative of the second. So the derivative of cosine x from that video is going to be a negative sine of x. So times, so we'll go ahead and multiply this like that, negative sine of x. Sorry, I've got a lot of parentheses going on here. But now we have the second term right here, which our second term is cosine of x, times the derivative of our first. So the derivative of sine x is going to be cosine x. So now we can go ahead and simplify these together. So we have a negative sine squared of x, because we have a sine x times a negative sine x, so it's negative sine squared. Plus, we have a cosine times a cosine, that's going to be cosine squared of x. And that's going to be our derivative right here. So I know also what a lot of you are thinking is, well, we have a negative sine squared plus cosine squared. Can't we just make that negative 1? Well, we can't, because no matter how we do this, if you want to take this negative out, well, you have to take a negative out here. So even if you try to factor a negative, it would be sine squared minus cosine squared. We can't use that nice identity where it says that's equal to 1. So this is as simplified as it's going to get. So I'm going to do one more example. This one is going to be a little bit different. Let's say that we want to find the derivative of 3x squared times 3x plus 4. So, well, we have a product here. We have one function times another function, so we can use the product rule. So we're going to have our first term, which is 3x squared, times the derivative of the second term. And our derivative of this, well, the derivative of 3x is 3, the derivative of 4 is 0. This is using the power rule. So this is going to be 3x squared times 3 plus the second term, which is 3x plus 4, times the derivative of the first. And the derivative of this using the power rule again is going to be 6x. Now we can simplify this a little bit. We get a 9x squared plus 6x times 3x is going to be 18x squared plus 4 times 6x is going to be 24x. We can combine these right here into 27x squared plus 24x. And that right there is going to be our derivative of 3x squared times 3x plus 4. But again, don't always use the product rule. Look at what we have here. We have a 3x squared and we have a 3x plus 4. There's nothing that we cannot multiply here. We can multiply this together into one term. So this is the same thing as saying, well, 3x squared times 3x, that's going to be 9x cubed, plus 3x squared times 4 is going to be 12x squared. Now this is just a nice power rule. So we can do the power rule of this. We're going to bring the 3 down to the front and subtract 1. We get 27x squared. Plus, we bring the 2 down front, 24x. Bam. That's the exact same thing that we got down here. These are the same thing, except this way was so much less. It's so much less work that we had to show. So yeah, you always want to make sure that you're looking for terms that can multiply. If they can multiply, a lot of times it's going to be easier to just go ahead and multiply them together and then just do the power rule. It's a lot easier that way. This right here, it does make sense. It's just more steps, and I think that there's a lot more room for error here. Especially if you start working with like negative signs and changing the signs of everything, it's just going to be a lot easier to go ahead and just multiply this together, get a quick answer, and be done with the problem. But yeah, that's all I have today for the product rule. My next video should be on the quotient rule, which is one of the next major derivative rules. I think this one is the easiest one that we'll go over, just because there's nothing too complex about doing this. You're just multiplying and adding. The only hard part is the derivatives, and that's just calculus. Calculus isn't easy. You got to do the derivatives. You got to know how to do them. But as long as you can do that, any of these rules are just going to be pretty self-explanatory. But yeah, that's going to be it for this one. Let me know if there's any questions or concerns, and I will see you next time.